Hey guys, it's Mr. Tracy. We are done with circles, and now we move on to the final unit of geometry, which is three-dimensional figures. And we're going to be finding the volumes, which I'll explain a little bit later, of a whole bunch of three-dimensional figures. This first page, we're going to kind of just breeze through, just so you get familiar with the types of figures we're talking about. All right. The first one is a prism. Okay, a prism is a solid with two bases that are congruent and parallel. Okay, and this figure in particular is called the triangular prism because the bases are triangles. So for any prism that you see, it's always going to have two bases. Okay, in this case, the two bases are triangles. All right, now base doesn't always have to be the top and bottom, but if you notice, we have the two bases that are triangles, and then there are 1, 2, 3 other sides to this figure, and those are all rectangles. So the way that we name a prism is by whatever shape the two bases are. In this case, the two bases are triangles, so this is a triangular prism. All right. Now, what's different about that and a pyramid? A pyramid is a solid that only has one base, and all of the faces meet at a point. Okay. This figure is a triangular pyramid because the base is a triangle. Okay. You could have a pyramid that's a rectangular pyramid. You could have a pyramid that's a pentagonal pyramid. Okay. This one in particular has a base that is a triangle, so we call that a triangular pyramid. All right. This one is like your can of soda or soup or whatever you want to look at it as. You guys have seen this before. This is called a cylinder. A cylinder is just a prism that has circular bases. All right. It has two bases, top and bottom here, and they are circles, so that's a cylinder. A cone is a pyramid with a circular base. This one you guys should be familiar with. Anybody who's ever had an ice cream cone or a snow cone or anything like that, we call them cones because that's the name of this geometric shape. It's a cone. And then last but not least, here are all of your spheres, okay, which is a solid, and each point is equidistant from the center, meaning I can draw a line from anywhere from the center of that sphere, okay? And it'll be the same exact distance away from the center to the outside, okay? You guys should be familiar with a lot of those. Now we're just gonna classify a couple. Now, taking a look at number 1. The question is this a pyramid or is this a prism? Well, how many bases does it have? It has one rectangular base, and all of the other bases, faces, are all triangles. So, since it only has one base, that's a rectangle, this is and all of the triangles meet at a same point, this is a pyramid. What type of pyramid? Well, we named that based on the base. The base here is a rectangle, so guess what? We call that a rectangular pyramid. Number 2, everyone should get that one. Super easy. That's a cone. How about this guy? What do we think this guy is? Well, how many bases does it have? There's one up here, one down here. They're both triangles, and anything that has two bases we call a prism. And then we name what type of prism is it? Well, that depends on the type of bases. The bases are triangles, so this is a triangular prism. How about this guy? Well, all of the faces around here meet at the same point. So this is a pyramid. Well, what type of pyramid is this? Well, we have to name that based on the base down here. What kind of a shape is that? 6-sided figure. 1, 2, 3, 4, 5, 6. 6-sided figure is a hexagon, so this is a hexagonal pyramid. This one is a cylinder. This one over here Okay, this is a plain old looking box. This one looks kind of like a shoe box. Okay, we call this, and we see this one a lot. Okay, this is a rectangular prism. How about over here? What are the bases of this particular figure here? How many faces does it have? Well, it has 1, 2, the back is 3, the left is 4, the bottom is 5, the top is 6. All right. What are the two bases? What shape are the two bases? Well, the bases are actually this guy and this guy. So since it has two bases that are parallel to each other, we call that a prism. What type of prism? Well, what shape are the bases? Those are trapezoids. So we call that a trapezoidal prism. This one, you've seen these any time in social studies where you talk about Egypt. Okay, these are the good old famous pyramids. And what type of pyramid is it? Well, that depends on what shape the base is. Looks like it's a rectangle. So this is a rectangular pyramid. How about this guy? What are the two bases here? Uno, dos. We have two bases, so it's definitely a prism. And what shape are the two bases? 5 sides, 1, 2, 3, 4, 5. We call that a pentagonal prism because the two bases are pentagons. All right. Down here, number 10, all of the faces meet at the same point, so that's definitely a pyramid. And what shape is the base down here? Well, that's a triangle, so this is a triangular pyramid. How about this guy? How many faces does number 11 have? Well, it has 1, the front, the back, 2, this long piece, 3, over here, 4, and then the bottom is 5. All right. Well, it looks like two of these faces are triangles and the rest are rectangles. So what do you think this is? If it has two parallel shapes of triangles, those are our bases. So I know whatever this is, it's going to be a triangular something. And since it has two faces that are parallel, it's definitely a prism. Last but not least, we have our, any time you've ever seen a ball, okay? These are all called spheres. Easy enough, right? Sweet, moving on. All right, now we are being asked to find the volume of all of these three-dimensional figures. Well, not all of them, some of them. We will do all of them eventually, but today we're going to do some of them. And we're going to start off with the volume of rectangular prisms or cubes. Okay? Cube wasn't mentioned on that last sheet, but a cube is just a three-dimensional figure. I'm going to do my best to draw one. Okay, a three-dimensional figure where all of the faces are squares. That would be a cube. Okay, like a die. Whenever you play a board game, you roll the dice. Dices are cube, or dice are cubes. Sorry. All right. So it says find the volume of each rectangular prism below. Well, what is volume? Volume is the amount of space that an object takes up. Okay, you've seen this in science for sure. Okay, you guys have talked about volume before, I know for a fact. Okay, and what the volume of a three-dimensional figure is how much space is inside this object. Think about it as if you were filling it up with water. How much water could I get in there? And the way that we find volume for rectangular prisms in particular is super easy. We just do L times W times H, which just stands for length times width times height. These are the most, usually the easiest, okay? If you take a look at number 1, all right, we have a length, we have a width, and we have a height. They give us all of them, 9, 17, 24. All right, so in order to find the volume of this particular figure, we have to, which is definitely a rectangular prism. The formula for that is I take the length, the width, and the height, and I multiply them all together. So the volume is going to be 9 times 17 times 24. Is my calculator over there? Yeah, it's right behind your computer. My lovely assistant is bringing over my calculator. Thank you very much.
You're welcome.
And we do 9 times 17 times 24, and we get 3,672. 3,672. Now, what are the units for volume? Well, the units for volume kind of depends on the dimensions that they gave us. All of the dimensions here were given to us in centimeters, so my volume is definitely going to be centimeters. All right, but the thing here is, whenever we're dealing in 3 dimensions, meaning there's a length, there's a width, there's a height, okay, we always put a little exponent of 3 here. Okay, so the volume of this particular rectangular prism is 3,672 centimeters cubed. Why is that? Well, what this is saying is, since the units are in centimeters, if I took a cube, which we talked about before, and this cube, let's say, was 1 centimeter cubed, meaning all of the dimensions around are 1. Okay, how many of these could I fit into this particular rectangular prism? Well, I could fit 3,672 of these little guys into here. So every single time that we are doing a volume problem, we're going to leave our units in cubed format, centimeters cubed. Super easy down here. Okay, rectangular prism. We got to find the volume. We have a length, we have a width, we have a height. All we got to do, multiply them all together. So we're going to do 10 times 14 times 4.5. which ends up being 10 times 14 times 4.5, 630. 630 watts. 630 inches cubed, because our units were in inches. And since we're finding volume, it's always got to be inches cubed. Last but not least, we have 8, we have 12, we have 39. Super easy. Rectangular prism volume is length times width times height. So I'm going to do 8 times 12 times 39, which ends up being 8 times 12 times 39, 3,744. Our units are feet, so cubic feet. That is a huge rectangular prism. That's probably like a storage container. All right, so rectangular prism, super easy. Now, we have to talk about all of the other prisms, which are a little bit more annoying. Okay. Okay, so for all other prisms, okay, whether it's a rectangular prism, I'm sorry, not a rectangular prism, whether it's a triangular prism, or a pentagonal prism, or a trapezoidal prism, okay, which is all based on whatever the two bases of the shape are, okay, for all other prisms other than rectangular, volume equals base times height. But it's not just the base that you're thinking of, okay? It's not a length. The capital B in this formula stands for the area of the base. And we multiply that by the height. So Listen carefully, because this could be a tiny bit confusing. In order to find the volume of a prism, I have to find the area of the base. So I have to be able to determine, out of all of the faces of this figure, which ones are the base. Okay? The bases are always the one that there's only two of. So in this case, I mean, this one's a little easy because they're showing us. Okay? Here's one of my bases. Here's my other base. So, what type of prism is this? Remember, a prism we name based on whatever shape the bases are. Well, the bases are triangles, so this is considered a triangular prism. So I have to find the area of the triangles. Okay, these will always be the same exact area. Okay, I have to find the area of the triangles, and then I have to multiply that by the height, or however far back, or however much space is in between the two bases. All right, let's do a couple of examples. I know it's a tiny bit confusing. All right, number 4. We have some sort of a figure, and we have a whole bunch of different dimensions here. All right. First things first, if I have to find the volume of each of these prisms, I have to figure out what type of prism am I dealing with. Okay, I have to establish which ones are the bases because I have to find the area of that base. So take a look at this carefully. How many faces are there in this figure? Well, there's this one up here, 1. There's this one on the bottom, 2. There's this one on the side, 3. To the right is 4. And then the front here is 5. Okay, so there's 5 faces. 2 of them are the same shape, and those are going to be our bases. Which 2 faces are my bases? The top and the bottom. So this is a triangular prism. So in order to find the volume of this, I need to find the area of the bases. Well, how do I find the area? Okay, capital B stands for area of the base. How do I find the area of, in this case, a triangle? Well, it's 1/2 times the base times the height. All right, so I have to figure out for these bases, what's the measure of the base of the triangle and what's the measure of the height of the triangle? Well, they give us that actually if we look closely. Okay. Anytime I see this little tiny right angle symbol, anytime I see that, that's going to be the height of the triangle. Okay. We call that an altitude, if you remember. I know it's been a while, but that's called an altitude. So they're telling us that the height of this triangle is 7.3 feet. So I'm going to pop that in for height. Now I need to figure out what's the base. Well, if this is the height of the triangle, this dimension has to be the base of the triangle. But it doesn't tell me how long that is down here. But I know for a fact that this dimension here is the same as this dimension here. Okay? If this side up here is 12 feet, this side down here has to be 12 feet also. So I know that the base of this triangle, this line right here, has to be 12 feet. All right? So I have to do 1/2 times 12 times 7.3. All right, and I get 43.8. All right, 43.8 what? Well, since this is area, this is feet squared. Area and volume are completely different. All right, 43.8 feet squared. So that's my B. That's the area of the base. That's the area of the base down here. Now I have to in order to find the volume, I have to take the area of the base and multiply it by the height. So how much space is in between this top triangle and this bottom triangle? There's a lot of different dimensions here. We have to be able to figure out how much space is in between this triangle and this triangle down here. And I know it's kind of hard to see, but this dimension here is the space between this triangle and this triangle. So this 5, that's our height. Stop growling. Enough already. So I have to take my area of the base, 43.8, multiply it by the height, which is 5, and I get 219. 219. My units are feet. This is volume, so the feet cubed, and that's my answer. All right. This one's probably a little bit easier to see, in my opinion. What kind of shape do I have here? Well, how many faces do I have? I have this side 1, this face 2, this face on the bottom 3, the front is 4, the back is 5. Which two faces are the same? Those are my two identical faces, okay? And they are triangles. So this is a triangular prism. So I have to figure out what's the area of the bases, and the bases are triangles, and then multiply that by the height, or the space between them. All right, so first things first, I have to find the area of the bases. The bases are triangles. So how do I do that? The area of a triangle is 1/2 of the base times the height. That's old news, you guys should know that. All right, and let's take a, it looks like all the information I need is on this front base right here. The base here looks like it's definitely 11. And then the height of this triangle is 5.4. And that's gonna give us our B. So 0.5 times 11 times 5.4, and I get 29.7. This is millimeters squared. All right, so that's our B. All I need is the height now. Now, height can be a little bit tricky because everybody thinks height is how high up something is. In this case, it's not really how high up it is. When we're talking about height in this case, we're talking about the space between the bases. All right, so the volume of this triangular prism is going to be the area of the base, which is 29.7, times how much space is there between the two bases. Here's one base, the front. Here's one face, the back. How much space is between them? There's a lot of dimensions here. How far apart are these two bases? They're 16 inches apart. I'm changing that to millimeters, guys. That should say millimeters, not inches. Okay, so since the two faces are 16 millimeters apart, that means that the height of this triangular prism is 16. And now I just got to multiply those two guys together. 29.7 times 16, 475.2. What's my units? Units are millimeters. And since this is volume, it's millimeters cubed. All right. I'm going to skip this one. You guys can thank me later. Moving on. We are going to do number 7, though. All right. So, what do I have here? How many faces am I dealing with? 1, 2, 3, 4, 5. There's 5 faces here. Which 2 faces are the bases, meaning the ones that are exactly the same? There's only 2 shapes here that are exactly the same. What are they? Here are my bases. The rest of the other faces are rectangles. Okay? They might be parallelograms, but I don't know. We'll call them rectangles for now. Alright, so this is a triangular prism. So remember, volume is the area of the bases times the height. So I have to find the area of these bases. Alright, how do I find the area of a triangle? I have to do area of a triangle is 1/2 the length of the base times the height. Alright, let's see. Well, they tell us that 28 kilometers, holy cow, that's a huge triangle, 28 kilometers high. Alright, so that's our height. And our base would be considered this dimension here, which unfortunately they don't give us. What they do give us, though, is that this is 32.5 kilometers long, which means this is also 32.5 kilometers long. Now, I kind of drew over it a little tiny bit, but you see this little right triangle symbol? Okay? That means that this is also a right angle as well. Now, down here, this is our base that I need to find the area of this triangle. But I don't have it. How can I figure out how long that is based on the information that's given to us already? Since these are right triangles, is there a way that we know to figure out the length of a missing side of a right triangle when I'm given the other 2 lengths? I'll give you a hint. It rhymes with Pythagorean theorem.
Is he related to Ed Sheeran?
Yes, exactly. And my wife knows what Pythagorean theorem is. And she doesn't even know math. What's Pythagorean theorem?
A squared plus B squared equals C squared.
There you go. A squared plus B squared equals C squared. So, I got to figure this out. Remember, the C always has to be my hypotenuse, which is this guy, 32.5. All right? So, A squared plus B squared equals C squared. And that'll give us the length of the base. 28 squared plus B squared equals 32.5 squared. All right, let's do some fancy footwork on the calculator. 28 squared is 784. 32.5 squared is 1056.25. All right, I'm going to subtract 784 from both sides. I get B squared equals 272.25. 272.25. And then I just got to take the square root of both. The square root of 272.25 is 16.5. All right, so down here is 16.5. All right, that's just the base. I know there's a lot of steps here. That's just the base of this triangle. Remember, I need to find the area of the base and multiply that by the height, which is the space between the bases. So what's the area of this triangle? Now I can figure that out since I have the base down here. Okay, area is 1/2 of the base times the height. All right, so the area, I'm gonna work up here since I'm running out of room. 1/2 base times height. Base is 16.5, height is 28. So the area of the bases is going to be 0.5 times 16.5 times 28. And I get 231. So 231 is the area of this triangle. And it's the area of this triangle also. Alright? Now remember, for volume though, volume is the area of the base times the space between them. Well, the area of those triangles is 231 times the space that's between them. Here's one base, here's the other. How much space is between them? Looks like, oh, they told us right here. 31 kilometers between them. So that's my height. And last but not least, the volume of this triangular prism is 231 times 31, which is 7,161 kilometers cubed, which is tremendous. There absolutely is no triangular prism that is this big on this planet. All right. We are going to skip this one as well. I don't like it. Moving on. All right, cylinders. There's a different formula that we need. Okay. The volume for cylinders is a completely different formula. It's pi times r squared times h. What do you think r squared stands for? Well, in a cylinder, the bases are circles. So r in circles usually stands for radius. And we're going to multiply that by the same thing. However much space is between the two bases, the height. Alright, cylinders are pretty easy, okay? We just need to figure out what's the radius, what's the height, okay? So, volume equals pi times the radius squared times the height. This is radius, this is height. Okay, well, what's the radius of this cylinder? Radius is the distance from the center to a point outside the circle. So the radius is 18. What do you think the height is? How much space is in between the two circles in this cylinder? 15. Easy enough, right? So I'm just going to pop it into my calculator exactly as I see it. We have pi 18 squared times 15, and I get 15,268.1403. We're going to round to the nearest tenth, let's say. So volume equals 15,268.1, and our units are inches, and since it's volume, it's going to be cubed. All right. Down here we have, is this a radius, this 11 here? No, this is a diameter. How do I figure out what the radius of a circle is if the diameter is 11? Just chop it in half. What's 11 divided by 2? I think it's 5.5. So that's our radius. 11 is the diameter, 5.5 is the radius, and then my height is the distance between the two circles, which is 21. Super easy. Volume equals pi times the radius, which is 5.5 squared, times the height, which is the distance between the two circles, which is 21. Pop it into my calculator as I see it. Pi, parentheses, 5.5 squared, parentheses, 21. Boom, 1995, that was a good year. 1995.69, which we would round to 0.7. So volume equals 1995.7. My units are meters. Since it's volume, they're cubed. All right. Now, save the best for last. Down here, number 11 is talking about this shape right here. It says, a cylinder with 2 centimeters in diameter is drilled through a triangular prism shown on the left. Find the volume of the prism. So imagine this. We have a triangular prism here. Then we took a drill and we drilled a hole. So that matter that was in there is gone. They want to know how much volume is left. Okay, because now I have a giant hole through this prism. All right, so first things first, I need to figure out what is the volume of the prism. Well, it's a triangular prism, so what are the bases? The bases are these two triangles. Here and here. There's a little tiny, it's hard to see, there's a little tiny right angle in there. Okay, so that's why I was paused for a second. I needed to double check to make sure that was a right angle. There is a right angle here. So remember, first things first, I gotta find the area of my two bases. All right, since there's a right angle there, that means 5 is a base and 5 is also a height. So the area of the two bases are going to be 1/2 times 5, the base, times 5, the height. That's going to be the area of my two bases. 5 times 5 is 25, and half of 25 is 12.5. Okay, that's the area of the two triangular bases. Okay, that's going to be RB. Now, how much space is between the two bases? I got one base up here, I got one down here. How much space is between them? 14. That's my H. So the volume for a triangular prism is the area of the base, which we found. The area of the base is 12.5, times the height, which is 14. So the volume of this prism here, the volume of the triangular prism, is the area of the base, which is 12.5, times the height, how much space is between them, 14, which ends up being the volume of the triangular prism ends up being 12.5 times 14, 175. That's the area of the whole triangular prism. But I drilled a hole through that prism. So all of that space is drilled out and we're left with a big giant hole all the way through our prism. So I have to subtract that out. Okay, that matter is completely gone. It turned to dust. Okay, so I have to figure out now what's the volume of that hole that I drilled. Think about a drill, if you've ever seen a drill. Okay, and think about it going through a wall or something. What type of a shape does it leave? Well, this is actually a cylinder, this shape. Okay, so I have to figure out what's the volume of that cylinder. And I'm going to subtract that from 175. All right, so now we're working on volume of the cylinder, the second part of the equation. All right, volume of the cylinder is pi times r squared times h. Well, what's the radius of this cylinder? It doesn't say it on this diagram here, but it does say that the cylinder has a 2 centimeter diameter. I don't care about diameter, I need a radius. So if there's a 2 centimeter diameter, that means our radius is going to be 1, because it's half the diameter. Now, what's the height? Well, the height is the space between the two bases, which ends up being 14 centimeters. So my h is 14. So in order to find the volume of the cylinder that we drilled out, we do pi times 1, which is the radius, squared, times 14. Pi 1 squared times 14, and I get 43.98. We'll round to the nearest hundredth. 43.98. So the volume of the whole prism before we drilled was 175. Then I took a drill and I drilled out 43.98. So in order to find what's left, the volume of what's left inside this prism is going to be 175 minus 43.98, which ends up being 131.02. We're talking in centimeters, and since it's volume, it's cubed. Alrighty, last but not least, a diagram of Eric's pool is shown to the left. He plans to fill his pool to a depth of 4 feet with a garden hose and has 80 feet cubed per hour flow rate. How many hours is it going to take to fill the pool? Alright, so first things first, we got to figure out how much water is going into the pool, so I need to figure out what's the volume of the pool. Here's the tricky part of the question though. Are we filling... How many times have you been in a pool and you go to the pool and the water is all the way at the brim of the pool? Never, right? Usually there's like a little space between the top of the pool and where the water ends. And they're telling us that he's filling it to a depth of 4 feet. Well, the height of the pool is 4.5 feet, so imagine we have water in here. So I don't need the volume of the entire pool. I just need how much water is going in. Okay, so I'm not going to use 4.5 feet as my height. I'm going to use 4 feet as my height. All right, so how much water is in the pool? Well, we got to figure out the volume of water and the volume of a cylinder. Volume of a cylinder is pi times r squared times h. What's the radius of this pool? Let's see. Well, the diameter is 27. If I cut 27 in half, I think that's 13.5. That's going to be our radius. The height, I'm going to use 4 feet because we're not filling it all the way to the brim. We're going to leave a little space. It says that right here. All right, so the volume of water in the pool is pi times r, which is 13.5 squared, times the height, which is 4. So the volume of water that's in the pool is pi 13.5 squared times 4. So the volume of water in the pool is 2,290.221, and that's feet cubed. All right, that's a lot of water, cubic feet of water. All right, we didn't answer the question though. It didn't say how much water is in the pool. Okay, it said how many hours is it going to take to fill the pool. Well, think about this. You throw a hose into the pool and you're filling up the pool, and water is going in at a rate of 80
So what?
I don't know, of 80 cubic feet per hour. So every hour, 80 of those cubic feet are being filled. Okay, every single hour. How long is it going to take to get to 2,290.221 feet? Well, the first hour, there's 80. After the second hour, there's 160 cubic feet. After the third hour, there's 240. I'm just counting. 80, 8, 16, 24, 32, 40. How many hours is it going to take me to get up to 2290? Well, there's a pretty easy solution to this. If there's 80 feet going in per hour, and I need to get to 2290, all I got to do is divide, and that's going to tell me how long it takes to fill the pool. It's going to take 28.63 hours. That's a long time. Alright guys, that's your introduction to volume. We will pick this back up on... Oh, we had a short week, so we'll pick this back up on Friday. You guys will have a new video, and I hope everybody is well, and I will talk to you all soon. Adios.